Hey everyone, welcome to Code Harmony. Today we are going to solve this question 1765, map of highest peak. This question has been asked in Google 3 times in the last 6 months and it is based out of BFS. Let's have a look on the problem statement. Here in this problem we will be given a grid named iswater of size m cross n, and that grid can only have values either 0 or 1. 0 means land and 1 means water. This is given, and what we have to perform? You have to assign height to every cell. Okay, we have to assign height to every cell in the grid. Following this condition, height should be non-negative, should be greater than or equal to 0, and height of water should be 0. Height of water cell is always 0. Let's say if 1 is in the grid, then it is a water cell, the height is 0. And along with that, height of any two adjacent cells should not cross the difference more than 1. Let's say height, this is having a height of 1. So all the adjacent cells, adjacent cell means they are touching by any of the edge, or you can say in the direction north, south, east and west. Their sides are touching. Okay. Their height delta should not cross 1. It means the maximum height of the touching cells can go till 2. This we have to do. We have to assign height, and keeping in mind that you are maximizing the height, and in the end what we have to return? Return the integer of heights containing all the heights. Okay. So let's have a quick revision of what is given to us. Given is water grid. 1 means it's a water cell, and 0 means it's a land. Its size is m cross n, water and land. It is also given in the problem statement that we are going to have at least one water. It means at least one water means some cells are definitely going to have a height of 0, because water is having height 0. Okay. This is given to us. What operation we have to perform? We have to assign heights. Okay. And keep in mind that height of water cell is 0, and delta of heights between any two adjacent cells should be less than or equal to 1. Keep in mind that you are maximizing height, and just return the height grid. Okay, let's say in this case these two were the water cell. The water cells are going to have a height of 0, and none of two adjacent cells are having a delta greater than 1. All are having delta less than or equal to 1. These are having a delta of 0. These two are having a delta which is 1. These two are having a delta 0. That is also allowed. Any two adjacent height should have a difference less than or equal to 1. So this is our problem statement. Now let's come to the approach. How we are going to solve this question? We will definitely be using breadth first search. Because in the problem statement it is given that some cell are water cell, and we definitely have a water cell in our grid. So we can directly say all the water cells, whatever is the number, they are definitely going to have a height of 0. And if we want to maximize the height, we can start from all the water cells and try to fill their adjacent cells. Fill their adjacent cell with height plus 1. Because we want to maximize the height plus 1. We can keep the same height as well, but that won't give us the maximum result. To maximize, just put all the neighboring cell as plus 1 height. So what are all the neighbors? These are the neighbors. These all are the neighbors. And these neighbors are going to have a height of initial height which is 0 plus 1. And now what about next? Next, we are going to see what are all the non-visited cells and which are adjacent to current cells. So cell adjacent to current cells are these two. And these two can have a height of 1 plus 1, 2. If I am keeping 2, none of the adjacent cells are crossing the constraint. Height of water cell is always 0, and difference should be less than or equal to 1. So when you are picking the adjacent cell, just try to keep the height plus 1. So this red color is my first level, and the blue color is my second level, and this purple color is my third level. And we are going level wise. Firstly, we are picking all the voter cell, and we are definitely going to start with voter cells. So these voter cells just put in the queue and apply the BFS. Okay, so how do we apply the BFS? Let me give you a quick revision. Copy and paste. For BFS, what we use is, we take a queue. In the queue, put all the voter cells 0, 2 and 1, 0. These are the voter cells. And the voter cells are going to have a height of 0, 0. Voter cells are going to have a height of 0 and all the neighboring cells. So these are the neighboring cells. Just pop, or you can say pull from the queue and add the neighboring cell 1, 2, 3, 4. And these neighboring cells are going to have height of 1. And then pull these 4 neighboring cells and put their neighboring cells. Their neighboring cells are these two. 2, 1 and 2, 2. And these 2, 2 are going to have 2 as a height. So maintain a height pointer. Height pointer is 0 for this level. Height is 1 for this level. Height is 2 for this level, and so on. So in this way we implement BFS using queue. If you are not able to understand it, just let me know. I will try to prepare another video in detail, or I will just try to address your question in the comment section below. Okay, so BFS is done. And along with this BFS, let's say this one is having neighboring nodes as this and this and this. Okay, and this one is going to have a neighboring node this. Now when we come to this 0, middle 0, this middle 0 is going to have a neighboring node which is on the right and the top. So to avoid conflicts, we are also going to keep track of visited nodes. It means all the cells which have been assigned with some height, we are not going to touch those cells again. If the height is assigned, so in this case, firstly these 2 heights were assigned. Then on the second phase, these 4 heights were assigned. In the third phase, only these 2 are assigned. So whatever is the visited node, we are not going to touch it. So keep track of visited array as well. Visited array and your queue, you have to keep track, and just fill the cell with a height variable. Height for the first level is 0, second level is 1 and 2 and onwards. So this is going to be our approach. What is the time and space complexity of this approach? Time is, we are visiting every node only once, because every node is going to the queue only once, and once it is pulled from the queue, then we are not touching it again. So, and how many nodes were there? M cross N. And what about the space? If we are considering this new grid to store height as an extra space, or we are also going to take a visited array of the same size. So space is also going to be in the size of M cross N. So this is the time and space complexity. Now let's have a look on the code. All the voter cells are going to have a height of 0. So it means I'm going to start my BFS from voter cell. So just capture all the voter cells, whatever is having a voter value equal to 1, then capture the cell, and along with that mark it as a visitor. I'm just taking visited array, and this is my answer to store the height, and this is the direction array to visit the neighboring nodes. Okay, so this is the first level, all the voter cells, and now capture the level size for every level. Just pick that level and set the height of that cell is equal to height pointer. Height pointer initially is 0, and after every level this height pointer is getting incremented to the next one. So let's say all the voting nodes are, let's say in this case 0, 1 is the voter node. So 0, 1 is on the first level. So this is 0. Answer of 0, 1 is 0, and check all the neighboring nodes. Neighboring nodes are 0, 0 and 1, 1. So for 0, 0 and 1, 1, I see whether this cell is valid, because it will also go up and right, but that is going to be out of bound, so we are not considering that. And along with that, it is not visited. If it is not visited and it is a valid cell, it means we can pick that item as in our next level. So just offer in the queue and mark it visited, and when we are going to pick the next level in this loop again, I'm going to assign the height of 1 to that level. So 0, 1 and 1, 1 is going to be assigned as a height of 1. And after that, at the third level, there is only one node remaining, and the height pointer is 1 currently. So when we are picking second level, after picking the second level, assigning the 1 height to the second level, in the end height is becoming equal to 2, and that will be assigned to the third level. And in the end, just return the answer. This is the code for this approach. I'm going to attach it in the description below. I hope you have understood the code. Thank you guys. Bye bye.